Hello, welcome to Computer Tech and More. Today we're going to be taking a look at the Teucer, also known as the Oddtone, as I found it on Amazon, and comparing it directly against the Noctua A12x25 because they are visually similar. Let's hop into the graphs and then we'll do an open box experience. Before we get into the graphs and the data, I want to show off what the spec information that I could find on this fan were. So it has like two names, and I know it as the Oddtone. That's what it's listed as on Amazon. And it is basically a bog standard 120 millimeter fan. It uses a fluid dynamic bearing, 12 volts. Power consumption is 0.15 amps. Speed range is 800 to 2,150 RPM. Airflow rated at 67.89 CFM. Static pressure is rated at 2.76 millimeters of H2O. And noise value is rated at 32.2 decibels, and mean time between failure is listed at 150,000 hours. And next to it, I have it compared against the A12x25 because I think they look fundamentally similar. Okay, first up is my case simulation test. The case simulation test puts the fans into a box that simulates more or less a standard size case that can hold a 180 millimeter size fan. In this test, there are a couple different ways of looking at it. The first one is how efficient is the fan at blowing, air front to back inside of a case. So in my opinion, the best case fan design in the world would be one that creates basically a cylinder shape of air that blows straight behind a fan, meaning that the fan would blow air at whatever its RPM was, or airspeed was at the very beginning, and would be a perfectly flat line front to back. But we don't live in an ideal world, and there are going to be aerodynamic losses due to the resistance of the air inside, your case, the box. So you're going to experience loss. So you want that loss to be as slow as possible. You want to have a nice, gentle slowdown from front to back, and you want that airspeed to be as high as possible for whatever your CPU cooler is. With higher airspeed for the placement of your CPU cooler indicates that the fan in the cooler doesn't have to work as hard to blow air through it, or more air is being pushed into it at a given speed, so that it's picking up and just accelerating it through more easily, thus improving its cooling efficiency. A fan that is very bad at creating a nice tight cone pushing through will spew air off to the sides, and you'll see a rapid drop in airspeed, actually rather like this fan, where it has a steep drop off right at the beginning for its airspeed, indicating that it shoots air off to the side rather than creating a nice concentrated airflow. The other way to look at this is basically as a case simulation, specifically case sizes. So I took it at a number of data points: 6 inches, 9 inches, 11 inches, and 14.5 inches. And each of those are representative of a different size case. So 6 inches is representative of small form factor cases that still need quite a bit of airflow, not quite as tight as the ultra tight small form factors, but still a small form factor nonetheless. 9 inches is representative of a very compact case that is still a front to back airflow type design. 11 inches is representative of a mid tower, something like the Corsair 550D or Meshify 2C. And 14.5 inches is representative of a large case, something like the Fractal Design Torrent. So as I alluded to before, you want the max amount of airspeed for your given cooler placement. So if you've got a compact case, you'd be looking at the 9 inch. If you've got a medium-sized case, you'd look at 11. If you've got a bigger case, you're going to be looking at the 14-inch mark. Now, how does this fan compare against other ones? Well, first up is noise normalized testing. This noise normalized is taken at 40 decibels by my measurement, with the microphone placed right next to the fan blade, basically. I'm doing a whole testing revamping, my whole test methodology, because I found some inconsistencies, and I'm going to go over it in that video when it's finally published and I finished recording all the new data. But I'll have a new sequence of videos for a majority of my fans that talk about where they were before and versus where they are now in noise normalized and other types of noise testing. The control fan on this graph is 3 parts the A12x25 to 1 part the A14, both Noctua fans, where 140 millimeter fans tend to a little bit better in case airflow tests than 120. So I really wanted to be able to incorporate a blending of 140 and 120 millimeter fans. But 120s tend to do a bit better at short throws, so that under 6-inch mark. Now, how does the Oddtone 120 compare against my control and the A12x25? Well, it starts off a little bit better, and then it's absolutely terrible. It might be one of the worst fans I've ever looked at. Let's just move on. Maybe it'll improve at 100%. Nope, it's probably worse. Yeah, we're going to just move on. It's not good at case airflow. And how does it compare against other ones? Well, on this graph, I have two fans that perform so well that they're off the chart. And I really want to show the differences in a condensed view. But basically, the Vinto Pro is the General Typhoon, and the Mobius 120 OC both performed really well with my current testing methodology. The Oddtone, on the other hand, well, at 9 inches, it's performing as badly as the NFS12B. So it's pretty bad. At 100% PWM fan signaling, it's not much better. Let's just move on. Oh, we're still here. So the 9-inch mark for airspeed versus decibels is basically a pretty good dividing line between where fans that shoot air off to the side still haven't lost all their airspeed, so it's fairly easy to measure, while the ones who are better at airflow still are pushing, will just dominate over top of them. And well, the Oddtone is pretty bad. Let's move on again. All right, now we're looking at airspeed through my CPU air cooler, the Noctua U12A. Oddtone. The left graph is RPM versus airspeed in a blade efficiency. It's how good those blades are at pushing air through, well, the CPU cooler. On the right graph, we have noise versus airspeed through that same cooler. How efficient is it at making as little noise as possible? So on the left graph, better fans on both graphs are going to be in the top left. And we have airspeed versus RPM, airspeed versus noise. Well, the Oddtone, ironically, does slightly outperform my control and the Noctua A12x25 across its RPM range. Not by a lot, but it is beating it out by a little bit. In terms of noise, well, once again, the Oddtone is actually kind of winning. It's not a lot better, but it is better. So if you're looking for a CPU cooler, it might be okay. But let's compare it against other stuff. Okay, I selected a bunch of fans to compare the Oddtone against and determine how it ranks. Well, in this graph, what sort of information are we looking for? Well, we know that I have a U12A, my CPU is the 11700K, my anemometer is accurate to within plus or minus 0.1 meters per second, so fans that are within that error range could be considered functionally equivalent. And the other last piece of information is this. This is a CPU wattage with an airspeed. That is the wattage that is associated with an airspeed on my particular CPU, the 11700K. My version of it, meaning the one I particularly own because everyone is slightly different, and my cooler. So if you have the same cooler as me and the same CPU as me, these wattages probably can be applied to yours, give or take. And I did a whole test. I have a whole video on it of testing out what wattage would equate to a clock speed, would a given airspeed going through my CPU cooler equate to. So basically I dropped my fan, I only had one fan attached to it, down to its minimum RPM and saw what wattage I got, incrementally increased the PWM fan signal on it, measured the airspeed, and determined what wattage the CPU drew. But computer tech and more. What if I don't have the same CPU air cooler as you? What if I don't have the same CPU as you? How can I use this data? Well, I'm glad you asked, because with every fan there is diminishing returns to how much air you push through it for how much extra heat it can dissipate. Just like on the CPU side, for every increase in wattage, there is a diminishing return to how much extra clock speed you get out of it. But let's say we're taking a look at this noise normalized value. Let's say your stock cooler came with the NFF12. For its noise value, it's only moving 0.7 meters per second of airflow. Well, if I upgraded to the Oddtone, I'd be getting 1.6 meters per second of airflow. That means I could get a significant improvement in how much wattage my CPU drew, or I get improvement in my temperature of the CPU, or I could take that and go, well, I didn't like Computer Tech and More's noise value. I think it was a little bit high. You turn back the dial on it so that your PWM fan signal is a little bit lower. You lower that airspeed, and now you have a quieter fan that is performing just as well as your stock one, maybe even slightly better. So those are the ways you would basically be able to use this data. Taking a look at things at 100% PWM fan signaling, and the Oddtone maxes out at 1,850 RPM for me, which is a far cry difference from what its rated spec was. So I think it's a pretty bad knockoff, where either there's huge quality problems with it or something else, because it should be getting like 500 more RPM. So, but for its given RPM, it's actually moving a pretty solid amount of air at a fairly reasonable noise level. So it's moving 1.8 meters per second of air at 45 decibels, putting it better than the Arctic P12, the P12 Redux, functionally similar to the Tough Fan 12 and the A12x25. Mind, it is a little bit slower, 0.1 meters per second, which may not seem like a lot, but it's probably at least 5 watts of cool or extra thermal headroom on your CPU cooler. Looking at this fan of cooler airspeed versus decibels, we can see how it ranks. It is highlighted in orange, this orange, and it's sort of top middle of the graph. I'd say it's doing pretty well, but the major problem with it is that it's just missing its maximum top end that a lot of other fans have. And I don't know if there was a problem with my particular unit. I don't know if this is an inconsistency with their manufacturing. It's too hard to know. I only ordered one of them to test, but it was not performing at the spec that it was supposed to. Now on to CFM testing. CFM is kind of the scientific test. It's, in my opinion, not as valid for testing out fans for your computer, because you're essentially placing the fan up against a tube, and you're blowing the air down the tube, and you're measuring the airspeed coming out of it at the end of it, and you know the base of the surface area of the tube, so you're able to calculate a airspeed per area, or airspeed per volume per airspeed, whatever. And you're able to get what CFM is, which is cubic feet per minute, which is the volumetric flow rate. So it hides a lot of the inconsistencies in a fan, because you're placing it up against the tube. If a fan tends to shoot air off to the sides, the walls of the chamber that it's in are going to still direct the air down the tube. So it's going to hide the fact that it's shooting the air off to the sides and make a fan look like it's performing better than it is in a case airflow application. What it is good at validating is it's functionally similar to placing the fan next to a radiator, an AIO, or a heatsink, because those devices naturally tend to straighten out the airflow going through it. So let's say you want to place this at the front of your case blowing through an AIO. Well, the air going through it would be straightened and then would come out going in more or less straight lines. So I don't really like the test. But I did the test just for you all, And we can see that it's basically functionally equivalent to the Noctua or my control fan in RPM versus CFM, and in noise versus CFM, it is almost identical. Comparing against other fans, it ranks towards the top in noise normalized values, which I believe we saw with the heatsink testing. And if we take a look at it at 100%, well, it's in the same sort of position it was before, shifted towards the bottom middle. It's still not a bad place for it to be, but it is kind of making my point that this one had some errors, problems with the whatever controls the PWM fan signal in it. And CFM versus decibel rating, how does it rank? Well, it looks very similar to how it went through the heatsink. It's right here in orange, and it's sort of the top end of what I consider the good category, but not the best category. Let's go to our open box experience. All right, now that we've done the main section of the graphs, we're going to do the open box experience. So I found this fan on Amazon under the name Oddtone or Oddtone 120. And on the box, it obviously says, well, it's a Teucer, so Teucer. I'm not sure exactly how to pronounce that. Obviously, some Chinese branding on it. And the box itself is pretty basic. It has some basic information on it, hydraulic bearing, how many amps, millimeters of H2O. Does it say airflow on it? I guess it doesn't. I can't see it on there. And in the box, it just comes with some very basic screws that are just, they're not even painted black. They're just metal in color. So let's go ahead and take a closer look at the fan and compare it to a Noctua A12x25 because I think they're visually very similar. So first and foremost, why do I think they are visually very similar? Well, if you take a close look at the fan blades, you can see it has these little ribs on it that are visually almost identical to the Noctua A12x25. It's basically like this Chinese brand took the fan blade design and went copy-paste. Now, they're not exactly the same. The angle, the ending on it, it doesn't have a sharp point. It's rounded. The gap to the edge is visually not as tight as the A12, but they are certainly very similar. The hub diameter, I need to compare calipers, but they appear to be very similar in size, as well as, well, the mounting system in the middle. So all this leads me to believe that they probably got a hold of this fan blade and then copy-paste and tweaked it a little bit just to be like, hey, look, we made something a little bit different, so they can't have a lawsuit. It's got the rubber pads. Let's see if they're the same size. Almost. They're not as deep as Noctua's, so they're not going to be compatible with Noctua's rubber vibration system. Okay, going over a couple features on the frame itself. So Noctua has this stepped inlet that they're pretty famous for, which inlays the fan blade from the edge a little bit. The Oddtone, there are ribs there, but they don't actually inlay the fan into the frame a little bit. But the vibration pads do raise it up just a little bit. When I did a pull configuration test, I found that this fan made essentially no noise, a lot like the Noctua. So that means that its blade design or the gap distance that it creates just is enough to produce very little noise while this is in a pull configuration on your CPU cooler, whether that be a radiator or a heatsink style cooler. So now I want to go into a little bit more detail about this fan and talk about how I think the blade design has to do with its performance that I found in my testing. So as we saw from the graphs, in airflow testing, or case airflow, it had very poor performance, while in heatsink performance, it was good overall in all aspects. Although this fan does have odd behavior in that it has no RPM change from 20% to 50% PWM signals. So if you kind of need stepped performance difference, so it going 20, 30, 40, and incremental increases in RPM, this is not a good choice. However, if you're just looking for something to hook up to a radiator or heatsink, this might be an okay choice if you're okay with its noise levels at the RPMs it does run at, as we basically saw from my data collection. So the blades themselves are a hybrid style, a little bit of a airfoil shape. It's got sort of a cupping in the back, and it obviously has these flow guides, but the frame itself lacks a lot of features that you see on the Noctua. And I think that's why it's just not quite as good in airflow testing. It just doesn't guide the air or funnel it in the same way. And its performance being slightly different because of, well, the gaps around the edges. Although I did find it to be good, again, in all aspects for the CPU cooler. So it does run fairly silently, so they have a good motor, a good bearing in there, and that sort of thing. So it's fairly impressive considering this fan's price point. So I kind of talked about this in my Noctua A12 review, but these guides on here, well, they're actually just that. They're guides. A good analogy would be what you see on an airplane wing, how they often have a little winglet ribs sticking out on the bottom or the top of the wing. Though that is there to help straighten the airflow as the air flows over it. And that is fundamentally what these do. It helps guide the air as the fan is spinning around and around, the air hits it and is sort of funneled where they want it to go. Whether this company actually did the engineering work behind it is another matter, like Noctua is famous for doing, and its longevity of the bearing is outside the scope of my testing. So I have no idea how long it will run. Before the price, you could get several of them and potentially have them run as long as one high-quality Noctua fan, but that's a risk that you yourself have to determine if you want to take or not. I don't think I have anything more to say on... Oh, I didn't talk about the frame itself. So the frame itself is very squared off. So if you have two fans sitting next to each other, so I know that this is a Noctua, but it means that it'll create a pretty good pressure seal for putting onto a radiator. On a heatsink, it matters a little bit less because you tend to have just one fan on it and they're a little bit less pressure sensitive. But on radiators, it tends to be more important, especially as you have more than one fan on most radiators these days. But having a good square frame is important if you also have a single fan radiator in a lot of pre-built systems. So overall, the frame design on this leads itself to being good in pressure applications, as well as for sealing and not allowing air gaps to not reduce its performance. Well, now I think I've said everything about this fan. Let's move on to my value proposition. Okay, now we're in the value proposition. So first up, the Oddtone 120 is a $13 fan. Value proposition is calculated by the airspeed divided by the number of dollars. How much money does it cost? So if it has good performance at a very cheap price, that's going to make it look like it's a much better value. What I'm not able to test for is longevity. I just don't have that capability. I'd like to add to it at some point in the future, but I need that help from viewers like you, signing from a Patreon, and even getting sponsors. But I'm not there yet, so it's out of my scope. So how does the Oddtone do? Well, at that 6-inch mark, it's doing really well. At 100% PW fan signaling, it is still doing pretty well. It's towards the top. Let's see how it does at the next data point. Now we're looking at it 11 inches. Avoid it at all cost. Don't buy it. Don't buy it for bigger cases. Just don't. Let's move on. Okay, going through the CPU cooler. Yeah, it's doing really well. It's ranked towards the top, especially at noise normalized values. Prior to this, the Storm T3, the Storm series from Antec was doing significantly better. The P12 Max, it's beaten that by a little bit. But once we're looking at 100% PWM fan signaling, it's dropped back. Mind, it's still a good choice. It's not that it's bad. It's just that other fans are doing better. The TLG12 is doing better than it. The TLC12 is doing better than it. The Antec Storms, and of course the Arctic P12 Max. So on CPU coolers, you do tend to need that 100% PWM fan signal is more important than the noise normalized value, but both are kind of important, so you want to weigh both factors, I guess, on this. And if you're on an ultra tight budget, you're going to want to pay close attention to these graphs, because this is where you're going to get the best bang for your buck to get the max amount of performance for your least amount of your money. If you have on a budget, but you've got some leeway and you want to get something nicer to either upgrade your noise performance or upgrade your airspeed performance, something like that, or maybe you want some RGB lights, well, then you would weigh this performance per dollar with the other graphs and determine what is the most important to you, or me showing off the RGB lighting to determine what's the most important to you. If you got unlimited budget, buy whatever you want. And last but not least, CFM testing. Basically it's the same story as the AirCooler testing. No real surprises or overall changes here. So where does that leave me with the conclusion for this fan? Well, if you're buying it as a case fan, do not, I repeat, do not buy this fan as a case fan. There are so many better fans out there. If you're buying it for a CPU cooler, radiator, or something like that to save a buck, well, other than my concerns about longevity and quality control issues with it, because mine was not achieving its maximum RPM that it was supposed to be spec'd out for, it should do okay. It should be fine for that type of application. I would have no major concerns there. Reasons for buying: it looks like a Noctua, but in white. Noctua currently doesn't have a white model. Other than that, I guess we'll just wrap it up. Thank you for watching my video. If you've got constructive criticism for me on ways I can improve my video, please go ahead and leave them in the comment section down below. I do read every comment, and every video I do try to improve things a little bit. As far as testing in the future, well, if you want to see me test any fans in particular, please leave it in the comment section down below. Again, I will go hunting for fans to test in the future. I want to test what you all want to see. Just know that there may be a delay or lag time between when you request something and when I'm able to produce the video, just because of how much time it takes. Other than that, I have a Patreon page. Please check it out. It's viewers like you that help make this channel possible to grow and well, acquire better testing equipment to make everything more accurate, so that I compete with the big dogs. Other than that, we're going to show off the raw data here in a second. Well, that's the video. Thank you very much for watching. Subscribe for more content. I've got lots of fan videos on my channel, and if you would like to see me review a specific fan, please leave it in the comments down below, and check out my Patreon page. I'll see you next time. Okay, right here is the raw data for the Oddtone. You are welcome to use this data for your own purposes. You can put it into Excel, whatever you want, make your own graphs. You are more than welcome to do it. If you've been watching my channel for some time, you're going to have the data for every single fan that I've tested. If you want to use it in a publication of some kind, I ask that you reference me and my channel, because I'm the one that created this data. It's more than an hour and a half to 2 hours worth of testing, followed by updating graphs and charts and changing colors for the specific fan for the review, putting it all into a PowerPoint presentation, getting some basic outline for a script, and then filming. Those last 3 pieces, not the data collection, is another like 3 hours of work. So it is a lot of work for me to make these videos. So yeah, leave credit where credit is due. And it's a labor of love. I'm very interested in fans. I'm actually an aerospace engineer, so it's a side passion of mine. And I really do thank each and every one of you for watching. And I hope to see you again here on Computer Tech and More. And have a great day.